So again, we have the equation y equals 2x squared plus x. We're asked to find this when x equals -3 and dx over dt equals 2. This and this implies that both y and x are functions of time. That's why I put that red dot underneath. So it's right here, and we want to differentiate both sides. What do I get on the left when I differentiate y?
One.
So when I differentiate,
dt.
exactly, this piece is dy over dt. Now here, you cannot say 4x. You have to say 4x times the inner function prime.
dx over dt.
Exactly. Plus, I differentiate x, which is a function of time. You cannot say 1.
dx over dt.
Dx over dt. It's done. Now I will say fine when x is -3 and dx over dt is 2. Piece of cake, because this is -3 and this is 2. I have all numbers I need. 4 times 2 is 8, times 3 is -24, plus 2, -22. So what just happened? We were given a relationship between two functions. One function is x, function of time, and y is the second function, also function of time. Once we differentiated, we created another relationship that relates or has these derivatives, their rates of change. And we were asked to evaluate dy over dt when x is -3 and dx over dt is 2. And we just put them in and got the number. Okay?
Can we do another?
Oh, absolutely, absolutely. And we are going to review this all over again on Wednesday. Of course, Thursday I meant. Anything else you would like to pick from here? Anything?
Number 9.
Number 9. We want to look at number 9. Excellent. So that's my page 8. Page 8, number 9. Good. We have y equals e to 2x plus 1. Find dx over dt. They're changing the rules right now. Then they don't want dy over dt. They want that's fine. When x equals -2 and dy over dt is 2.5. Awesome. Great job. Perfect pick. Good. So this is the question. This is what
I
I'm
don't
asking.
think that's from the same one.
I'm sorry?
I don't think that's from the same question.
I do that a lot. Thank you.
No problem.
Given this, find, of course, when x is 4, thank you very much. When x is 4 and dy over dt is 2.5. No, dy over dt is 0.5. Okay, thank you so much. Okay, I'm checking now. I don't believe anything anymore. Okay, good. Excellent. So I have the function. I put my dots so I don't forget. A dot under x, how come? Because it's a function of time. And a dot under y. Y, how come? Because it's a function. This clearly tells me it's a function of time. Or t, a third variable, it doesn't matter. Okay, I'm ready now. We start from the left. What do I get on the left?
dy over dt.
Of course, of course. Once you understand, you cannot reverse the process. Now I have to be careful, and let me refresh your memory on e to a function prime is e to that function times the function prime. So e to the function, I have to write it as is, times the inner function prime, and you cannot not say just 2, because this is a function. So times 2 times
dx
over dt. That's it. So now they don't want this, but they want this. No problem. To solve for this, I will divide this piece as is by this. So then dx over dt is that, I'm sorry, over this, 2 times that. Done. So therefore, when x is 4, when dy over dx is 0.5. So dy over dt, of course. So the top, 0.5. The denominator, 2 times e. 2 times 4 is 8. 8 plus 1 is 9. This could possibly be a very, very small number. Divided by 2 and divided by e raised to the 9th power. My goodness. So approximately 3.085 times 10 to negative 5. So basically you can leave it as is. And that's it. Promise. We have 3 minutes. Let's choose another. That's all it takes. Any of these problems. Less than 3 minutes. So you want to choose, or I will. I want to choose 11. On the same page, 364. So in 11 we have y equals natural log x. They want us to find dy over dt when x is negative 9 and dx over dt is 0.25. I hope I copied from the same problem. Okay. No worries. So let's differentiate both sides. And remember, these are both functions of t. What do we get on the left-hand side?
dx over dt.
Dy, you mean? Yes. And on the right-hand side, first I have to differentiate natural log, and then the inner function. So first the natural log.
X.
Exactly. Times the inner function prime.
dx over dt.
Excellent. Done. That's it. I only need to plug in the numbers. When x is negative 9 and dx over dt is 0.5. So it's 1 over negative 9 times 0.5. 1 over negative 9 times 0.5. It's 2.5, of course. Sorry. 0.25. So it's negative 0.25 over 9. And it's done. That's it. I'm going to erase the whole thing. This is it. And put it up here. So the answer is negative 0.25 over 9. We have a relationship between the functions, and we have a relationship between their derivatives. That's called related rates. Related derivatives or related rates of change?